On task 6, this one deals with a linear system of equations. So whenever expanded, the first part asks us to graph two intersecting lines, because usually this is what happens, especially in Algebra 1 kind of class. And in Algebra 1 class, that's what your goal is when you're solving a system of equations, is that you're trying to find where the two lines intersect each other. And once again, these lines can be in whatever form. Now, you don't have to try to find a system of equations where you know exactly where the solution is. The point of Desmos is that it's finding that solution for you very simply, very quickly. So I'm just going to do mine in standard form just because I know you guys hate it. And also to demonstrate that it really, really doesn't matter what form your equations are in. Desmos will be able to easily graph them and solve stuff for you effortlessly. Okay, and then let's say that I make this a 2x. Let's do a minus 9y, and then maybe equals 13, something along those crazy lines. Now, here's what it means to solve a system of equations, especially linear ones, is that you're trying to find where the two lines intersect. You don't have to bother to eyeball the thing. What I would do is just click on the intersection. Some crazy decimal numbers here. And now, since we're dealing with whole numbers or integers here, there's no way these are irrational. They're just some weird rational numbers. We're not taking any kind of square roots. It's just that they're not nice, neat decimal numbers. It would be no fun whatsoever to solve this thing by hand, but that's not the point. It's, hey, how do I have Desmos, how do I have it set up so that it's so free, basically, to solve this system of equations for me? Now, the next one wants me to import the intersection point, the ordered pair, into the expression list. And I'll do this just like I did the intercepts on a previous one of these activities here. So just to the right of that ordered pair, there's a little icon that has an arrow pointing to a rectangle. And that rectangle is just supposed to be a representation of Desmos here, where it's pointing to putting it into the expression list, which is exactly what I wanted to do. So if I just click on that thing, bam, it puts it into the expression list. Unfortunately, it puts it way down here at the bottom, but that's okay. We can kind of click and drag this thing, and drag this thing. This happens every single time. Drag this thing all the way up to where I want it. There we go. Maybe even I turn the label on, and so I can see that actual point pop up there on my screen. Okay? But like I said, you could do this by hand. Probably the best way to do this is substitution or elimination. If you actually had pencil and graph paper, there's no way that you could ever get that level of accuracy there. But Desmos it just basically shrugs at it. It's so easy. So I just want to show you maybe a more complicated example. Let's say, for example, I had a linear equation, and collapse this thing, linear equation, something like y is equal to 1/4. Oh, that label is still on there. 1/4, not y. Nope. X minus 3. Okay, so I have a linear equation. And then this weird, strange system, it also has a parabola. So y is equal to a 2x squared. And now I need to get this thing to actually intersect the line. So actually, I'll go down here. I'll make that minus. Let's make it even crazier here. So maybe a minus 3x and maybe plus 1. Yeah, that's good. All right. And now, if I were being tasked with solving this new system of equations, there's no way that you're solving it by elimination. You could, on paper, do this thing by substitution, because you have what y is equal to. You could just substitute that in, this 1/4 x minus 3 in for y into this equation. You could solve it. You could do this by hand, but we're looking for opportunities to save ourselves some time. Once we get those things graphed, what's it mean to find the solution to a system of equations? What it means is find the intersection of the two graphs. And this one has two solutions, obviously, because it hits the line hits the parabola at two different places. Here's the one over here on the right. Again, I'm going to pull this in and I'll turn on the label and then maybe click and drag this guy up to where these lines are. And then maybe I do the exact same thing on the second one, the one that's over here on the left-hand side. Crazy, crazy numbers. Doesn't matter. Bam. I can pull these things in, maybe show the label, and then just like I did before, just drag this thing where I want it to go. Now, I will show you in a future activity a very nifty way to be able to pull the numbers out of the ordered pair so that you can do some algebra on those numbers. Because maybe that x value, this negative 2.4435, for example, maybe what I have to do is take that number and I have to put it into some other equation. So I'll show you how, without having to type it, how I can pull that exact value out of the parentheses and so I can use it in a problem. But that's secret information for another activity.